respect it or don't come. If you can play it, are you recording it? Good. Am I gonna be able to continue, or am I gonna be still only gonna talk again while I'm doing this? Can I continue or not?
Yes, sir.
I got one yes.
Yes.
Degree triangle, 60-degree triangle. Yesterday we figured out a 30-degree triangle. Do you remember this? I had a 30-degree triangle. You guys calculated the width to be the square root of 3 over 2 and the height to be 1/2. Of course, the radius is 1, or the hypotenuse is 1, because that's what we did. Is that correct? That should be the very first point on your guys' unit circle, correct?
Wait, I have a question.
Yes.
So, like, so the, like, sign is always the height.
Yes. Okay. This is the right triangle, and this is the 30-degree triangle. What's the other angle? 60 degrees. So if I rewrote this as a 60-degree angle, when its opposite be the square root of 3 over 2 and 1/2. Opposite of it, adjacent. Opposite, adjacent. Does that make any sense? Does that make any sense? Okay. So that would mean to me that this point right here would be the 30-degree point flipped. Questions on that? I got a 45-degree angle. It's a right angle, or right triangle. What do we know about it? Yes, Carson. Exactly. Two legs would be the same. But what are they? I'm hearing we go half of the, what do we do here? We double that and divide by the square root of that? Is that right? No.
No, we can't have that.
We just divide it by the square root of 2. Yes?
Could you write like the 36 times our way and the 45 times our way, like the basic like side rule?
The rules?
Yeah.
I think we have those rules right there. Okay. Now we can't have a radical sign in the bottom. Did we talk about how to pump this up to the top?
Yep. Yeah. Cheerleader method.
Cheerleading method. So that's the square root of 2 over 2. So when I go to my unit circle right here, square root of 2 over 2. Square root of 2 over 2. Carson, this should be the exact same because it's a 45, 45, 90 degree triangle. Perfect. Yes.
I'm confused how you did the square root of 2 over 2. But
You understand how I got 1 over the square root of 2?
Yes.
Okay. Miss UTech taught you guys, if you multiply that by 1, which just means the top and the bottom are the exact same. What's 1 times the square root of 2? What's the square root of 2 times the square root of 2? Square root of 4. What's the square root of 4? And that's how we got it. Now I taught everyone this shortcut, cheerleader cheer. And they all think it's really cool. Maybe one of them can learn you it good. While we're doing this, let's figure out these points right here, just for fun. Nobody know what this point would be right here?
1, 0.
1, 0. Because the radius is 1, and it's right on the x-axis. So what's this point right here? Hmm?
0, 1.
0, 1. Alright, now we're going to start looking for the pattern. Leah? How far is this angle away from 90 degrees?
30 degrees.
So let's go on the other side at 30 degrees. What would be on the other side 9 degrees? That's 30 degrees away. Perfect. So this angle here is 120. Which is 2 pi over 3. Okay, I'm gonna have one more angle in here. Can anybody figure out what the angle is, what that angle would be?
150.
150. Which is 5 pi over 6. Now, as I said, it's a pattern. These numbers, as they go away from 90, are going to kind of reflect each other. Because this is now a 45 degree, 45, 90 triangle. This is a 60, 90 degree triangle if I keep on going back to the x-axis. So the numbers are going to look very similar. 1/2 square root of 3 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 2 over 2. 1/2. Now, Bracken, what does the red tell me in this quadrant? What's negative? 4. So that means the pattern is similar, but if cosine and sine or cosine and x are negative here, those numbers actually become negatives because it's in the second quadrant. Red's negative, purple's positive, negative, positive, negative, positive. Carrying it all the way through for you guys. Questions on this? Can Mary, tell me what that point is.
Negative 1, 0.
Am I going too slow on this for you? You sure? It's okay if you say yes.
Looks like it.
Okay, let's go down to the next quadrant. Again, I'm gonna follow my pattern. This was 30 degrees away, so that was 210 degrees. 235. That's 240, 250. Did I do that right? No, that's 225. And that's 240, that's better. 225 and 240. For those keeping score at home, 7 pi over 6, 5 pi over 4, 4 pi over 3. Again, the numbers are going to follow the pattern that we have here. The first one's going to be a square root of 3 over 2, the second one's going to be a half. First one's going to be square root of 2 over 2, and the second one's going to be square root of 2 over 2. Third one's going to be a 1/2 and a square root of 3 over 2. The question is, can anybody tell me what the signs will be in front of those? Reckon. Both negative, because it says right here in this quadrant, they're both negative. So let's just write those numbers. I'm going to do it on one color pen at once so I don't have to keep changing pens. Square root of 3 over 2. Negative square root of 2 over 2. Negative 1/2. And this is going to be 0. 1/2 negative. Negative square root of 2 over 2. Negative square root of 3 over 2. Negative 1. Are you starting to see the pattern? Again, from the x-axis, I have a 30-degree angle, 45-degree angle, 60-degree angle. degrees, 315, 330. That should be 5 pi over 3, 7 pi over 4, and 11 pi over 6. Jasmine, how are my numbers going to behave in this quadrant?
X is positive, Y is negative.
Perfect. And I'm just following the pattern again. 1/2. Square root of 2 over 2. Square root of 3 over 2. Square root, oh, wrong color. Square root of 3 over 2. Square root of 2 over 2. 1/2, as Jasmine said, my y's all have to be negative because it's negative in that quadrant.
Is the pi amounts, the radian amount, something we just need to memorize?
Yeah. Or you can always use my converter. Degrees times, or theta times pi divided by 180 and just leave it as a fraction. Okay. Let's get a little remedial on this. What's my definition of sine looking at that triangle? What is it?
All over y. Or just y.
Which is what we studied, and that's what's on your unit circle, correct? Nothing new here. Can someone else tell me what cosine is on this triangle? Emma? X over 1 or just X, correct? What's tangent?
Y over x.
Can I also define tangent? Is sine over cosine? If you just told me sine equals y and cosine equals x, and if y over x is tangent, then can I not just substitute and say sine over cosine? Yes or no? Okay. So let's have a little bit of magic. I'm gonna call him Elena. Elena, what's cosine at 30 degrees?
Square root of 3 over 2.
Very good. Genesis, what's sine at 30 degrees?
1/2.
Any questions how we got that? So let's see if this makes sense. Ready, Clayton? I'm gonna call on you in a second. Tangent of 30 degrees, according to you guys, is just sine of 30 degrees over cosine of 30 degrees. Is that correct? Beck, would you mind shutting the door? I do not like being interrupted during my lecture by anybody. So could I argue it's just 1/2 over the square root of 3 over 2?
Yeah, so it'll be 2 over the square root
So-
of 6.
What does that mean?
Keep, change, flip.
Keep, change, flip. Okay. Alright, I think we have the answer on Becca. Can you answer as a student speaking?
No.
Oh, it's gone.
Oh.
That's too bad for them. What do you guys see there? Clayton, your turn. Twos cancel. Which is 1 over square root of 3. What's my problem? Bracket.
You have to, yeah.
How do I move the radical up? That's not a fun way of saying it.
Bump up the radical.
Bump that radical up. Keep that base.
What's that?
So I am adding into this tangent in black, and I just calculated that tangent is the square root of 3 over 3 at 60 degrees. You just helped me calculate it.
So tangent should be the hypotenuse.
Yes.
So it's square root of 3 over 3 1.
Hmm?
It's square root of 3 over 3 1.
Square root of 3 over 3.
But it's a unit circle, so for a tangent, it's square root of 3 over 3.
But you never use the hypotenuse to calculate tangent. You always have to use the two legs, never the hypotenuse.
Right.
So this will be the same thing for any radius. It's always gonna be that proportion.
Yeah, 'cause it's an angle, not a side.
Yep.
So it's-
Okay.
It's always gonna be square root of 3 over 3.
Yep. Tangent of 45 degrees. Do I have to show you sine over cosine 45 degrees, or if we just read the numbers for me off the unit circle, Carson? 45 degrees. What's my sine and what's my cosine?
Square root of 2 over 2 and square root of 2 over 2.
Carson, what do you notice about the top and the bottom?
They're the same.
What does that mean? Bree, what is the tangent of 60 degrees?
Oh, well, the cosine of sine is 1/2 and then square root of 3 over 2.
Remember, the cosine goes on the bottom, the sine goes on the top.
Oh. Wait. Yeah. I'm sorry.
Sine goes on top. What's the sine?
Square root of 3 over 2.
What's the cosine?
1/2.
Keep doing the math, Bree.
Square root of 3 times 2 is square root of 6.
Okay, why don't you take a look at this?
Oh, no, the 2's canceled. Sorry.
Questions on this? No? Good. Let's do a couple more. Then we can fast forward to the rest of the circle and do it quickly. We'll go with Brecken. Yeah, you're gonna do the first Brecken does the first one and then Brecken does the second one.
Okay, my next is
So, are you guys ready?
Yeah.
I just will put a little line through it so it looks like the number 0. Alright. Let's do the other Brecken. What does it equal though? No.
Side by side, legal.
It breaks the universe.
You can never divide by 0. Therefore, it's undefined. So right here, it is undefined. Okay, so it goes 0, square root of 3 over 3, 1, square root of 3, undefined. Now I'm going to work my pattern backwards. Square root of 3, 1, square root of 3 over 3, 0. Now I want to analyze this, Leah. Are these going to be positive numbers or negative numbers? Correct. Why? because the x's are negative and the y's are positive. A positive divided by a negative is a negative. Therefore, tangent will be negative right here. Negative, negative, negative. Let's continue the pattern. Square root of 3 over 3, 1. Square root of 3, undefined. Shauna, am I negative or positive? Because y is negative in this quadrant.
Positive.
Why am I positive if y is negative?
Because two negatives makes a positive.
Oh, because x is also negative. So a negative and a negative is a positive. In fact, if you guys even bothered to graph this on your test when you had to do cotangent and tangent, you guys should have known that it made a weird shape going up, and there was asymptotes all along the way. That's these holes right here, the undefined at 1 and negative 1. Just in case you were interested. Okay, let's complete the pattern. Miss Kirkby, square root of 3, 1, square root of 3 over 3. Positive or negative? Why? There's one negative. The y's are negative in this quadrant. And now you have an extremely powerful tool known as the unit circle. Yes.
Is the tangent value for 240 degrees, that's 2 square root of 5 over 3?
What number? 240?
Yeah.
It's just square root of 3. No, that should only be here, and here, here, and here. Remember, everything's just moving away from the y or the x-axis in different ways. Questions on this? Good. Let's move on. I know, I'm ignoring it because I'm trying to teach. Would you like to answer it? Does this all look familiar? I want to see I'm running over there to answer the phone. It's not my fault if it hangs up before I get there. Darn. I tried.
Yeah. Try to work on this one.
No questions?
Nope.
Good. Let's talk about stepbrothers.
I have a question. What's your question?
Each one of these have a stepbrother. You guys had a quick exposure to the stepbrothers. Cosecant, secant, and cotangent.
So the stepbrother of sine is cosine?
Yes.
To see.
Yes. I remember S to C. It makes me happy to do this. The letter S goes to the letter C. It's just a stupid thing I have in my head to remind myself. S to C, C to S. Cosine goes to secant. So, these things are the exact inverses of each other. So if sine is the y side over r, cosine or cosecant is r over y. Secant is r over x, and cotangents of x over y. Not this week, but later I'll show you when those can actually be more efficient in solving problems than using your traditional 3 trig functions. These are the 6 trig functions. 6 trig functions. Any questions on that? No? Good. Because in this homework you're going to have some problems like this. Actually, I've had that on my note card. I'll give you guys a second to write that down.
Are the inverses written as like cosecant theta or just?
Yes. Sorry, thank you. Cosecant theta, theta, and theta. Wait. What's the sine of 225 degrees? Any problem figuring that out? Okay, let me ask you this. What's the cosecant, of 225 degrees? Raise your hand if you think you can guess that one. What do you think, Carson? I would love the negative right in front of the whole fraction. But yeah. Flip it. All you do is flip it to get cosecant, but I got a little bit of a problem. The radical sign's at the bottom.
It just means for it
How do I move it to the top? Bump, bump, bump that radical up. Which I will keep that -2 there. Keep that base. What happens now, Bracken? So the cosecant at 225 degrees is -2. There's going to be some problems on it where they're going to use your unit circle and you have to use it to be able to manipulate to get cosecant, secant, or cotangent of these specific angles on your unit circle. Do you understand that? Good. Then there's going to be one more part you're going to have to try and know how to do. And please mind you, this last 2 weeks you were supposed to understand all this for your CPM.
Can you make cosecant?
Yes. Otherwise they wouldn't put it on the test.
Wow.
Sorry that we're doing it mild. No, sorry, not sorry. You're going to get a triangle like this. You can get this question. Find all 6 trig functions. Whenever I get a problem like that, I list them just for my own organizations. Sine theta, cosecant theta equals. Cosine theta S to C, C to S, secant theta, tangent theta, cotangent theta. Who can give me sine theta? Raise your hand. Looking at my right triangle, who can give me sine theta? Shauna.
4/5.
4/5. Which cosecant theta is then what, Shauna?
5/4.
Just flip the fraction. Bracken, can you give me cosine? 3/5. What would secant be? Leah, I want tangent. It's y/x. No, that 4/3. I'm sorry. Yes. What would cotangent then be? That is enough to give you guys all you need to get every single homework problem done and done correctly. Now, I have sent you guys an email with a PDF file of the textbook. Now, please pay attention. If you scroll down to find page 2 or 356, and you get that little Google thing on the bottom that tells you that you've gone 356 pages into the book, that will only take you to page 311, not page 356. Because that Google thing is also counting the table of contents, the acknowledgement of all the people involved, an introduction. So you actually are going to have to look in the top corner of the page until you see 356. Number 2, in the back of the book is all the odd answers. I highly encourage you to use them to check your work. Or when I was in your age, with my twisted mind, sometimes if I didn't know how to do a problem and I saw the answer, I could actually work backwards to figure out how to do the problem. You are expected to show work. I do not do well with people who just write the answers down for the odd ones and think they're going to get half credit. Any questions? Okay, yes. Oh! Anybody, this is my laminating folder. Make sure you have your name on the back or something, so it comes back to you. And just because you're not here doesn't mean I can't send the folder a second time.